Good morning, good afternoon, and good evening. My name is Harold Mangubat, and the topic that I choose and that I want to discuss is about trees. So let's start. So before I start, I want to read the agenda or the topics covered. So first is the tree introduction. Second one is the tree traversals, and the last one is the examples. So let's proceed. The introduction of tree is efficient algorithms for finding items in a list are built using trees. They can be applied to methods that create effective codes, such as Huffman coding reducing data transport and storage expenses. Trees are useful for modeling process that involves making a series of decisions. Building these models can assist in figuring out how computationally complex algorithms, like sorting algorithm that operate according to a series of adjustment, overview of trees. So let's proceed to our next slides. The tree data structure terminology. So the first is the node. A node is a structure that may contain a value or condition or represent a separate data structure. The next one is the root, the top node in a tree or the prime ancestor. The next one is the child, a node directly connected to another node when moving away from the root, an immediate or descendant. The next one is the parent, the converse notion of child and immediate ancestor. The next one is leaf, a node with no children. The next one is internal node, a node with at least one child. So the next is the depth, the distance between a node and the root. The next one is the level, the number of edges between a node and the root plus 1. The next one is the height, the number of edges and the longest path between a node and a descendant leaf. And the vertices with V as an ancestor are connected to be descendants of V. The ancestor of vertex other than the root are the vertices in the path from the root to this vertex, excluding the vertex itself and including the root. That is its parent's parent, and so on, until the root is reached. The next one is the left subtree. The left subtree of a node includes all the nodes that are descendants of the node's left child. This means it consists of the node's left child, the left child's left subtree, and the left child's right subtree. So the last one is the right subtree. The right subtree of a node includes all the nodes that are descendants of the node's right child. It consists of the node's right, the right child's left subtree, and the right child's right subtree. So here is the examples of tree. So first is the node. The node is number 1 and the left subtree numbers is are 2, 4, 5, 8, 9, 10, and 11. So the next one is the right subtree. The right subtree numbers are 3, 6, 7, 13, and 14. So this is my examples with answer. So the first question is what is the root node? So the root node in this tree is 1. What are the leaves vertices? So the leaf vertices in this tree is 6, 14, 4, 8, 9, 11, 12, 15, 16, 17, 18, and 19. So bakit natin sila tinawag na leaves? Kasi sila yung mga walang anak dito sa ating tree example. So the next question is what are the siblings of vertex 17? So the vertex 17 and the siblings is 18 and 19. So bakit natin sinabi na 18 and 19? So dito sa tree na to, makikita natin na yung 17 ay magkakatabi sila ni 18 and 19. And sila din yung anak ni number 13. Kaya kaya tinawag natin silang siblings. C, 18 and 19. The next question is what is the level of the node labeled 10? So the label of node 10 is 2 since the 10 is from the level 2. So we start to count in 0 level. So 0, 1, and 2. Kaya yung level ng 10 is 2. The next question is, what are the internal nodes are there in tree? So the internal nodes there in tree is 2, 3, 5, 7, 10, and 13. The next question is, what is the height of the tree? So the height of the tree is number 3. So since mag-start tayo ng bilang sa 0 and may apat silang level dito, so mag-start tayo sa 0, 1, 2, and 3. Kaya tinawag na uh, ang height ng tree is number 3. The next question is, can you find a descendant of the node labeled 2? The next question is, can you find descendants of the node labeled 2? So the descendants of node labeled 2 is 6, 7, 8, and 9. Next question is, what are the ancestors of the node labeled 15? So the ancestors of node labeled 15 is 10, 3, and 1. The last question is, what is the degree of node 6? So the degree of node 6 is number 3. Kasi mag-start lagi tayo sa 0 hanggang makarating tayo sa labeled node ng which is the number 6. The next topic or agenda is what is tree traversals. Tree traversal, also known as tree search, is a process of visiting each node of a tree data structure. During tree traversal, you visit each node of a tree exactly once and perform an operation on the nodes like checking the node data, search, or updating the node. So we have three types of tree traversal algorithms. So first is in order traversal is visit the current node of after visiting all nodes inside the left subtree but before visiting any node within the right subtree. So the next one is the pre-order traversal. Visit the current node before visiting any nodes inside left or right subtree. The last one is the post-order traversal, visiting the current node after visiting all nodes of left and right subtree. So we have examples, two examples in the next slide. So this is my first example, which is in order traversal. So to make it easy to find in order traversal, so we have a clue, which is in order traversal is equals to left, root, right. So let's find the in order traversal. So first is nodes in the following order, which is the 4, 10, 12, 15, 18, 12, 24, 25, 31, 35, 44, 50, 66, 70, and 90. So this is the in order traversal in this example. So let's proceed to our next slide and next example. So my next example is pre-order traversal. So like in order traversal, we have an easy way to find it. So we have clue. So the clue is pre-order traversal is equals to root, left, right. So let's find the pre-order traversal in this example. So the first number is 25, 15, 10, 4, 12, 22, 18, 24, 50, 35, 31, 44, 70, 66, and 90. So this is the pre-order traversal in this example. So this is my last example, which is post-order traversal. So we have also here a clue to find the pre-order traversal, which is the pre-order traversal is equals to left, right, root. So let's find the post-order traversal in this example. So the first number is 11, 12, 10, 18, 22, 15, 44, 35, 64, 66, 90, 70, 50, and 25. So this is the answer of a pre-order traversal in this example. I have here a bonus example that I have answered, but in equation naman siya. So I have here a pre-order traversal, in-order traversal, and post-order traversal. So yan. So this is my bonus example. So that's it. I hope that you have learned something in my video presentation. Once again, my name is Harold Mangubat and thank you for your listening.